Welcome to part 6. This is going to be a long one, so let's get started. This is going to be tines and tone bars. Now, this is a hard part. So far we've created some basic parts, and I think you'll enjoy the solution that I've come up with for this. I'm going to try a few ideas for tone generators, but my plan is to try something that's very time based in this series, and in future videos I might look at reeds and other ideas I have, but I'm not going to cover that here. I think for now is a good time to state that the goal of this project is to try and make something cheap, simple, and from materials that are readily available. This comes with compromise, and this section's no exception. As always, let's look at what already exists. So Fender Rhodes uses a tine and tonebar combination to create the tone for each note. Here's an example. It features a larger bar, and this is the tone bar. This allows more energy to be stored while not moving much air. This gives it a lot of sustain to the note. Bolted onto this is a tine assembly. This features a metal block. I don't think there's anything too special about this part. Feel free to tell me if I'm wrong. And then it features a hole that the tine is fixed to. Now, this is the interesting part, the tine. Now, I'm led to believe this is special. I think there's magic in this part, how it's cold worked to give the tine extra strength and life. I believe this is created from piano wire grade steel that is processed with a Torrington rotary swager. This features rotating hammers that work a piece many times a second, and these hammers hit the workpiece every time they go past a bearing. These mechanical hammers reduce the size of the steel wire down to the required size. I believe this process creates residual stresses in the wire, which also aids in the fatigue performance of the part. As the hammers rotate, the surface finish is very good, reducing the possibility of defects, which once more would reduce the fatigue life. I expect this process to create residual stresses in the tine. But is stress bad? Well, normally you could say yes, but not in this case. If we bend something, it has elastic motion, and we let go and it'll spring back to its original shape. If you go beyond this, then we plastically bend this, and when we let go, it only springs back part of the way. And once we've let go, there's residual stresses now on each side of the bend. One side's in tension and the other one's in compression. Now we can repeat that second bend, and there's no extra plastic deformation introduced. So this swaging process actually creates negative compressive stresses in the tine, so it takes more load and deflection for the same stress. So here we have a tone generator assembly from a Fender Rhodes piano. I've moved the tuning spring to give it a perfect 100 Hz resonant frequency. I've created a CAD model of this very tine, and then we can analyse this geometry with finite element analysis. This is a process of taking something complex and we're going to break it down into smaller sections where the maths is known. So the geometry is chopped up into regular shapes where we know how the maths of this part will react. And this creates a mesh of this geometry. We can then apply steel properties to the shape, and then we can fix the screw holes as if it's been held. And then we can do a natural resonant frequency analysis. This finds the first 10 eigenvalue frequencies for this geometry. So this gives the ability to extract what the natural resonant frequencies are, and also what the mode shapes are. So this is the first mode. This is the second mode. This is the third mode. And this is the fourth mode. We can see some of these are quite unlikely to occur. So we know the tone created is 100 Hz, so we know that this mode is the correct one. If we record the sounds from this and we do a frequency analysis of what other peaks occur, we can compare this to the other natural resonant frequencies. We could tweak the shape and the geometry of the tone bar and the tine geometry, but I think that's beyond the scope of this project. For now, this is all we're going to cover. So back to what we can do. Okay, so I have two options. We can try and create a swage tine, but the tools are expensive. I haven't really seen any of these tools come up for sale locally. I found out there's two of these machines in the UK, but nowhere near me. And I don't think they'll be open for me to process my own material and do something that they're not necessarily set up for. And option two is we make tines that are cheaper, that maybe are designed a little bit more like guitar strings, once more, easy to replace, don't cost much, and that would be a bonus. So the cheap way is the way we're going to go. So here's a CAD model of my design. Now this is much simpler. I've used 1.5mm diameter piano wire for the tine. We have not included twists or anything special for the tone generator, or tone bars. To size the design, I've used finite element analysis again. I've studied the Fender Rhodes design to look at what frequencies this resonates at, and this matches the audio that I tested the part for. So when creating my Simplified design, I just need to make sure that my part creates the same frequency response. So to create the tone bars, I've got some 3x10 metal section. I've cut this to length, and then I've 3D printed a jig that allows me to line a punch, and then we can drill the holes we need in this. As I said before, on the Fender Rhodes it features a twist, and yeah, my design doesn't. I expect this to respond differently and have different harmonics and overtones, and maybe the sustain won't be as long because we're going to be moving more air as this vibrates. But remember, a Fender Rhodes piano can still be found, and we don't need to recreate one. We're quite happy to create something a little bit different. For the tine holder, I'm going to have a brass square section. So we've gone 3/8 inch, 9.5mm. And the reason I've chose this is it's relatively easy to work with. So I need to drill a hole for the tine and a hole attached to the bolt. Once more, I've created a little jig that allows me to center punch these holes. I can then drill these holes, and then the tapped hole I've tapped for an M5 bolt. And bringing metric to the electric pianos. So I've oversized the hole that I've made for the tine. I've gone for 2mm. And this leads us to how we're going to attach this. I'm going to braze the tine into this holder. As there's a larger area, it's quite a long connection. We should get quite a large area that we can react to any forces over, so I wouldn't expect any high stresses. It also means the tine breaks. You can simply cut a new wire and then heat the holder, and then you can replace the wire. So only replacing the wire is possible now. And then finally, yes, some music wire. We've got 1.5mm diameter piano wire, cut to length, and then we can just braze it into place. We can bolt it together, and then we can test this. So I'm aiming to release a new part every week, but there's actually a bit more work that went into each part. I think I've been working on this project for about 6 months, and I've given up a few times and thought it was too hard, and then came back to this and worked out the problems. And I think this was the hardest part, coming up with a tine that would work. First I tried some fence wire. This is called double strength. Double what? I have no idea. This has a 1.6 OD, so close to the specification of Fender Rhodes. The wire feels reasonably easy to bend, which tells me it isn't that strong. But I did create a tine with it, and it seems to work okay. And then I used the piano wire. I thought I'll try one more thing. I'll try bike spokes. Now, most bike spokes are made of stainless steel and come in a 1.8, 2.2mm typical size. But being stainless steel creates an issue, is that they're not magnetic, so the pickup system won't work with these, which rules them out. But I did research and I did find out that vintage bicycles tend to use carbon steel spokes, which would be galvanized, and that would work with these pickups. And also, to save weight on bike spokes, sometimes they're buttered, and this is a process of reducing the size of the spoke in the middle by a cold working process, often using a Torrington machine to swage the spokes. Wait there. I'm sure this machine was mentioned before. So surely bike spokes are expensive then, if they're made the same way as tines? No? No, you can get a pack of 40 for less than $40. Motorbike wheel shops can come up with custom spoke shapes and sizes. Here is a buttered motorbike spoke. This is way bigger than what we actually need for an electric piano, but it shows the swaging process and it also shows the butting, and we can see that it looks pretty similar to a tine, and it is interestingly very similar how these are manufactured. If anyone has a lead on a galvanized buttered bike spoke that we can test, please get in touch. I'd love to try it. If I was to hazard a guess, I would guess these were the tines that Harold originally came up with, using bike spokes. That would work. They are quite cheap, readily available, and I imagine that could have been the inspiration. The size of the tine matches quite well with the bike standards, and yeah, being carbon steel would have been the material that was most common when the Rhodes piano was first created. So I found some non-buttered galvanized spokes that are slightly thicker than what we want. So I've ordered some of these and created a spoke tine. This doesn't have the taper but does have a bigger OD. So this will sound different. And yeah, these seem to work well. But remember, these need to be galvanized. Stainless steel spokes won't work. And the zinc that is on them needs to be removed before you heat them up. So my plan to go forward is to use the piano wire, as I think this is the most readily available and will give me the most consistent results. I think it's really satisfying to get this far. I expected some issues, and I can actually see light at the end of the tunnel now with this project. And I'm getting quite excited that the only part from a Fender Rhodes in my test setup is the hammer tips and the spring. We've created a tine and we've created a tone bar, and I think it should last. Will it last as long as the reproductions on sale? Probably not, but these will cost a fraction of the cost, which for creating a full piano makes it a viable option. I think brazing the connection between the tine and the tine holder might be a risk, but it also is a cheap way of doing it, makes it replaceable, and it might actually improve sustain as the connection's going to be really solid. There's no opportunity for gaps there. We are mixing different metals and this could create a corrosion issue. The positives are, I believe we can now create our own tines. I believe this method can be used to make a full set of tines this way, and I think that could be the next step. And on that, I think we've talked long enough on this one. Thank you for watching. Yeah, let me know what you think. Please subscribe. Until next time.